This is a lesson on Boyle's Law, and I've got right here the idea of what Boyle's Law is. So you need to learn this statement. You'll need to know that Boyle's Law is volume and pressure inversely proportional. What does it mean if something's inversely proportional? Anybody know?
It's oppositely proportional.
That's right. When one goes up, the other one goes down, correct? When one goes up, the other one goes down. So in this case, if you hold everything else constant, if pressure goes up, volume should go down, or vice versa, right? If pressure goes down, volume should go up. That's what it means by inversely proportional. Now, I have a formula here. It's the same formula you already have on your note sheet. We're going to use this formula. I don't know what happened to this 2 here. I'm going to finish it off here. That's going to be a 2. V1 times P1 equals V2 times P2. All right? We're going to use that formula in order to do calculations. Here's the thing I want you to know, though. When you do these calculations, you need to be able to recognize what units are. All right? What kind of units do volume come in? Centimeters cubed, something cubed. Could be centimeters cubed, decimeters cubed, any kind. What's another unit that volume comes in? Milliliters. And when I say milliliters, it's anything that ends in liters. It could be milliliters, liters, decaliters, anything like that. But you're going to have, it could either be a cubic unit or a liter unit. And that's going to be your things for volume. What kind of units do pressure come in? Does anybody know? Because this is new for you. Anybody have any idea what pressure comes in? Let me give you these, because I don't think we've covered these before. Pressure comes in something called an atmosphere. ATM is abbreviated atmosphere. I'm going to write that out here just so you remember it. Okay, so you can measure pressure in atmospheres. You can measure pressure in millimeters of mercury. Millimeters of mercury. Or you can measure it in kilopascals. And I think somewhere I'll probably have that listed again. So atmospheres, millimeters of mercury. Let's see if I can fit this here. And kilopascals. The reason I tell you these units is because, you know, you might have a math problem and it doesn't say the pressure is. It says so-and-so is measured in 2 atmospheres. So you have to know that 2 ATM is a pressure unit. So learn these units for pressure and the units for volume. Okay? Any questions there? All right, so this is the second page of that notebook, the Smartboard notebook page, and this is a sample problem. This uses Boyle's Law. So I already know that this is going to use Boyle's Law, but let's suppose you were on a problem, you had a worksheet or something, and you didn't know it was going to be Boyle's Law. How would you do that? And here's what I would advise you to do. And when you get your test papers, I would literally do this with your questions. When you read the problem, I would go ahead and label things that you know. So it says, a sample of oxygen gas has a volume of this. So everybody agree that that is a volume, right? And when its pressure is this, so this is a pressure, okay? Does everybody agree that that volume was measured at the same time as that pressure? So if I give this volume 1, this has to be pressure 1 because they were measured together. They're measured at the same time. Then it says, what will the volume, in other words, that's what I don't know. So I don't know this volume, and I'm going to label that 2, and I'm going to put equals question mark because that's what I don't know. What will the volume of the gas be at a pressure of this? This is pressure 2, because the volume I don't know, I want to be measured at this pressure. So that since they're measured together, they will have the same subscripts if the temperature remains constant. And if it ever says something remains constant, that means it's not involved in the formula because it doesn't change. If you put it in the formula, it just cancels itself out, so why put it there to begin with? I want you to notice here, I have 2 volumes and 2 pressures. The only equation that I gave you with gas laws is Boyle's Law that has 2 volumes and 2 pressures in it. So I automatically know that I'm going to use V1 P1 equals V2 P2. And I'm just going to plug the numbers in. So after you figure out what your quotient is, it's just algebra. It's not chemistry anymore. So I'm just going to say 150 milliliters times 0.947 atmospheres equals V2, I don't know, times, that's not 30 negative, y'all, 0.987 atmospheres. V2 equals, now if you're doing algebra, folks, what are you going to do to solve for V2? I'm not going to subtract because it's multiplied. I'm going to do the opposite. I'm going to divide, right? Yeah, I'm going to divide. So I'm going to, does everybody agree that I'm going to say 150 times 0.947 and divide it by 0.987? Does everybody understand the algebra part of that?
Yes, ma'am.
Okay, so let's do that. Let me get a calculator. Let's figure out what this is. So 150 times 0.947 equals divided by 0.987, and I get 143.9 milliliters. The reason I know it's milliliters, two things. I'm finding volume, and when I divide, atmospheres would have canceled out. So it's easy to figure out what the unit is. Does anybody have any questions on that? Yes, ma'am. Okay, now this is still with Boyle's law, but what I want you to understand is sometimes you'll see this, STP, in a problem. And if you ever see STP, it doesn't mean the motor oil additive and all that kind of stuff. Here it means standard temperature and pressure. And so what will happen is you'll see STP in the problem, and sometimes it's at the beginning with the ones, and sometimes it's at the end with the twos. But what you have to know is that when you see STP, that means a number, okay? So if you look right here, I've written at the bottom. Now remember on that sheet I had you copy down? I gave you these numbers already. All right? Standard temperature means 0 degrees Celsius or 273 Kelvin. So if you ever see a problem that says standard temperature or STP, that's the number you use. It won't give you that number. It expects you to know that number. All right? If you ever see standard pressure, then it's going to use one of these. Well, how do you know which one to use? It depends on your pressure unit. If it asks you to find pressure in kilopascals, you're going to use 101.3. If it asks you to use pressure in atmospheres, you're going to use 1 atmosphere, so on and so forth. So, but the point is that you have to know these numbers. You have to know whenever the problem refers to standard temperature, what it means. If it refers to standard pressure, this is what it means. If it says STP, it's talking about one of each. All right? Questions about that? All right, so here's sample problem 2. A gas measures 546 milliliters. This is volume. Volume 1 at STP. That means this is going to have temperature 1 and pressure 1. Does everybody understand that? That because I say at STP, that's giving me a number. If the temperature is held constant, that means temperature is not involved. So if temperature is not involved, I don't even have to know that was standard temperature. I just gave it to you, but I don't have to know that. Temperature is held constant. What is the pressure? Pressure is what I don't know of a gas that is decreased to 486 milliliters. So this is now volume 2. I'm looking for pressure 2. When I see this, I automatically know Boyle's law. Volume 1, pressure 1 equals volume 2, pressure 2. By the way, do you understand how I know that's Boyle's law? 2 pressures, 2 volumes. That's the only equation I have with Boyle's law in it. So what I'm going to do is now plug these numbers in. 546 is my volume. Pressure 1, I can use whichever standard pressure I want because it's easy to multiply and divide by 1. I'm going to use 1 atm. Equals volume 2 is 486 milliliters of mercury. Excuse me, just milliliters. And I don't know pressure 2, so that's my X. All right. For those of you with, that are a little bit slow in your algebra, you already know that in order to solve for my X or my P2, I'm going to have to divide both sides by 486. Okay? Everybody understand that? So I'm going to divide this side by 486 and this side by 486. Which means that over here it canceled out, correct? All right, and look what happened to my units. Milliliters canceled out too, over here. Okay, so now I'm just going to do my math. I'm going to say 546 times 1 divided by 486 equals 1.12 atmospheres. The reason I know it's atmospheres is because that's the only thing that you can cancel out. So that equals my pressure too. Good? Questions?